Let's take a look at some probabilities given a table. So here we have a table, male and female, A, B, and C, and then we also have some total columns and rows. So for example, we can see that there are a total of 85 students in this survey. The probability of male. So the general rule is this equals the number of successes over the total number of events. That's our general probability rule. So we have the total number of successes, total number of males. Now because we have a column, we could either choose to add up the individual cells or take advantage that they already added them up for us. The number of males in this population, 24. The total number of events, again, we could add up these 4 cells, or we could add up these 3, or we could add up these 2, or we could take advantage that they've added them all up together, 85. This fraction does not reduce, so that is the simplified probability. Next up, the probability of getting a B. So again, we can take advantage of that they've already added up the individual B's, 20 and 7, to get 27, and the total, 85. And we can quickly jump straight to the answer, 27 over 85. This also does not reduce. That would be the answer. Now the probability of not C. We can do this in 2 ways. We do know the rule that that's 1 minus the probability of getting a C. So we can either choose to do the not C's, that would be add up all of these that are not C's, or add up the totals. Or we could do, and so what that would look like, 35 and 27 is 62 out of the total of 85. Or we could do 1 minus. The probability of getting a C, just one number, 23 out of 85. And you can verify that that gives you also 62 out of 85. The probability of female and B is most easily done with the table looking for the ones that are female and B. So there, B and female, there are 20 over the total 85. Now this fraction does reduce down to 4/17, so you'd want to do that. Finally, male or A. Here we have to worry about, there's 2 ways to do it. There's either a formula or there is just adding up from the table. All the males or all the B's. So if I were to highlight all the males, I would get these, or the A's, and we get these. Notice that these 8 students were counted when we counted up the males and counted when we counted up the A's. So we have to be careful that we don't double count those 8 students. So the 2 basic approaches, first off, just adding up these 4 numbers in this problem gives us all the males and also the females that got an A, therefore all the people that are male or got an A. So we could add up 8 plus 7 plus 9, those are the males, plus the other 27 females that got an A, dividing that by 85. This would give us, we do this since we're going to do it in two ways on the left, 51 out of 85. And this does reduce. You can divide by 17 and get 3/5. But we also have the rule, the OR rule. This would be the probability of male plus the probability of A minus the probability of male and A. So this rule double counts and then subtracts the double counting. So the probability of male, we look up, there are 24 out of 85, plus the probability of getting an A, there are 35 out of 85. And this is the situation where we are adding the 8 twice. So then the formula says subtract the probability of male and A. The male and A are those 8 people that were double counted. And that also gives us the 51 out of 85, which reduces to 3/5. So we can, I think it's the easiest with a table, make sure you don't double count, but count all of the cells that are male or A. That's all of these, male or A, and then just directly get 51. But you can also use our OR rule. And you can see that the 8 are double counted, and that's what the OR rule does, is double count and then subtract the double counting. All right, go ahead and pause the video and work on the question on the right. You should get 27 out of 65, 20 out of 65, which reduces to 4/13, 58 out of 65, 20 out of 65 again, which reduces to 4/13, and finally 30 out of 65, which reduces to 6/13. All right, I hope this helps.